So free electron theory of metals is proposed by Drude and Lorentz. Okay, the scientists Drude and Lorentz have proposed this free electron theory of metals. Okay, so according to this free electron theory, the electrical conduction in case of metals is taking place because of the free electrons. Okay, these assumptions are proposed by Drude and Lorentz. So let us take one by one. The following assumptions are made in the free electron theory. In conductors, there is a large number of free electrons. Okay, actually separated from the atoms. What do you mean by separated from the atoms? Separated from the atoms means they are not bounded to the nucleus. The electrons in the outermost shell are called as free electrons. Okay, free electrons. The electrons in the outermost shell are called as free electrons in case of conductors. That is in case of metals. Okay, and they are capable of moving freely in the interatomic spaces. Okay, they can move freely in the space between the atoms. That is the meaning of interatomic spaces. Okay, so those electrons will move in the presence of electric field. When electric field is applied, those electrons get accelerated in the direction opposite to the direction of applied field. Okay, that we have seen in the previous class. So these electrons are called as conduction electrons, are treated as an electron gas. This group of electrons is considered to be electron gas, just like they move just like the gas molecules in the gas sample. They will move just like the gas molecules. Okay, the electrons are performing random motion with all possible velocities like the gas molecules. Okay, so these electrons are performing random motion with all possible velocities like the gas molecules. Okay, so you have studied kinetic theory of gases. So in kinetic theory of gases, we have assumed that gas molecules perform random and continuous motion. Just like that gas molecules, electrons are going to move inside the metal. This is a classical theory. Don't confuse much. Okay, so that is the another postulate or assumption. Then third point says the mean kinetic energy of the electrons is equal to that of the gas molecules at the same temperature. The mean kinetic energy of the electron is just like that of gas molecule at the given temperature. That means half mv square. That equation is going to be used. Half mv square gives the kinetic energy, and total energy of the electron is only kinetic. Potential energy of the electron is neglected because it is going to be very small, or force of repulsion between the electron is neglected. So total energy of the electron is equal to its kinetic energy only. The positive ions in the metal occupy fixed position. They will not move. Only electrons are going to move. Okay, electrons matra move ಆಗ್ತದೆ. Positive ions will not move inside the metal. They are fixed to their position because their potential energy is greater, kinetic energy is less. For electrons, kinetic energy is greater, potential energy is very small. Okay, that point you have to remember. Next, what happens to the motion of the electron in the absence of electric field and in the presence of electric field? I have discussed in the previous class also. Just I will recall. In the absence of electric field, the free electrons move about irregularly in the whole volume of the metal like the gas molecules. Okay, gas molecule move adange free electrons move ಆಗ್ತವೆ. In the absence of electric field, there is no particular direction, there is no particular velocity. They will move with random direction and random velocity. When an electric field is applied between the ends of the conductor, there will be an electron drift in the direction opposite to the direction of electric field, since the electrons carry a negative charge. Okay, so electrons will start to move in a particular direction when electric field is applied. When battery is connected, electrons will move in a particular direction. Okay, and the direction of motion of electron is opposite to the direction of electric field, because electrons are negatively charged particles. These electrons will attract it towards the positive terminal of the battery. Whereas electric field is directed from positive to negative. Electrons will move in the direction from negative to positive direction. That is opposite direction. Okay. Electric field apply madadaga, electrons will start to move in a single direction. They will get accelerated. Okay, that is what this particular point says. The effect of electric field is to impart a velocity called drift velocity to the electron in addition to the velocity of random motion. So drift velocity and the define what is drift velocity? It is the velocity acquired by the electron in the presence of electric field. Remember this definition. Drift velocity is the velocity acquired by the electron in the presence of electric field. Okay, so this is called as drift velocity. So here I have defined it again. So different terms I have to define in order to understand the concepts. First term is drift velocity. Drift velocity is the average velocity of the free electrons with which they move towards the positive terminal under the influence of electric field. Okay, so drift velocity andrenu, it is the velocity of the electron in the influence of electric field. That is drift velocity. Okay, so I will not explain further. Fast. Then mobility. Mobility, it is defined as the drift velocity of the charge carrier per unit applied electric field. Mobility andrenu, it is the drift velocity per unit electric field. So mobility mu is defined as Vd divided by E. What is E here? E is electric field. Drift velocity per unit electric field. Okay, so this is called as mobility. Note the difference between drift velocity and mobility. Drift velocity is the velocity of the free electrons under the influence of electric field. Mobility is, it is the drift velocity per unit electric field. Note the difference. Okay, Vd by E, the mobility. Okay, that is mobility of the electron. That is going to be very useful in the study of electrical conductivity. Then next is collision time, or it is also called as relaxation time. The average time taken by the free electron between two successive collisions is called as collision time. I already told you, electrons are moving just like gas molecules. Because of that, their random motion, they will collide with other electrons. Okay, and also they will collide with the other ions present in the metal. Ions jotenu collide ಆಗ್ತದೆ, other electrons jote kuda collide ಆಗ್ತದೆ. The average time between one collision to next collision, that is called as collision time. Okay, so it is also called as relaxation time. We'll see further. Before that, mean free path andre enu? It is the average distance traveled by free electrons between two successive collisions. It is called as mean free path. Okay, already you have studied in kinetic theory of gases. ಒಂದು collision ಇಂದ ಮತ್ತೊಂದು collision ಆಗಬೇಕಾದ್ರೆ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಮೂವ್ ಆಗ್ತದೆ. Okay, that path is called mean free path. It is the distance to success. It is defined as time taken by a free electron to reach its equilibrium position from. What do you mean by equilibrium position here? Equilibrium position ಅಂತಂದ್ರೆ constant drift velocity. Constant drift velocity, equilibrium position ಅಂದ್ರೆ ಅನ್ಈಕ್ವಲ್ ವೆಲಾಸಿಟಿ ಇಂದ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಅಕ್ವೈರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ಬೇಕಲ್ಲ, ದಟ್ ಟೈಮ್ ಇಸ್ ಕಾಲ್ಡ್ as relaxation time. Okay, otherwise it is also called as the time taken between one collision to next collision. Okay, these 5 points you have to remember. I will recall. One, drift velocity. Drift velocity ಅಂದ್ರೆ ಏನು? It is the velocity of the electron in the presence of electric field. Mobility. Mobility ಅಂದ್ರೆ ಏನು? Mobility is the drift velocity per unit electric field. It is given by VD by E. Collision time ಅಂದ್ರೆ it is the average time taken by the free electron between two successive collisions. Okay, ಒಂದು collision ಇಂದ next collision ಗೆ time ಎಷ್ಟು ಬೇಕು, that is called as collision time. Mean free path, it is the average distance traveled by a free electron between two successive collisions. Okay, then relaxation time ಅಂದ್ರೆ it is the time taken by a free electron to reach its equilibrium position from the disturbed position. It is called as relaxation time. Okay, so then share ಮಾಡ್ತೇನೆ, ನಾನು ನೋಟ್ಸ್ ಶೇರ್ ಮಾಡ್ತೇನೆ. ಇದು ಸ್ವಲ್ಪ ಡೆಫಿನೇಷನ್ಸ್ ಇದೆ ಅಷ್ಟೇ. ಸೊ ವಿಲ್ ಟ್ರೈ ಟು ಕಂಪ್ಲೀಟ್ ದಿ ಒನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಡೆರಿವೇಶನ್ ಟುಡೇ. ಓಕೆ, ಒಂದು ಎಲೆಕ್ಟ್ರಿಕಲ್ ಕಂಡಕ್ಟಿವಿಟಿ ಡೆರಿವೇಶನ್ ಇದೆ, ಸ್ಮಾಲ್ ಡೆರಿವೇಶನ್, ಬಟ್ ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಐ ವಿಲ್ ಶೇರ್ ದಿ ನೋಟ್ಸ್. ಓಕೆ, next we will take this derivation. All of you carefully observe this, and it is going to be very important. A simple derivation of electrical conductivity. Electrical conductivity ಅಂದ್ರೆ ಏನು? It is a reciprocal of resistivity. Okay, and this equation is called as Ohm's law. Basically, electrical conductivity sigma is defined as the rate of charge flow across unit area in a conductor per unit potential gradient. Okay, I will repeat once again. Electrical conductivity sigma is defined as the rate of charge flow across unit area in a conductor per unit potential gradient. Okay, rate of charge flow ಅಂದ್ರೆ ಏನದು? Anyone? Rate of flow of charge ಅಂದ್ರೆ ಏನದು?
Current density.
No, J andre current density. Just I am taking rate of charge flow. Rate of charge flow andre current across unit area, per unit area ಅಂತಂದ್ರೆ that is current density. Okay, right, you are saying right, but ನಮ್ಮ ಕ್ವಶನ್ ಏನಾಗಿತ್ತು? ರೇಟ್ ಆಫ್ ಚಾರ್ಜ್ ಫ್ಲೋ ಅಂದ್ರೆ ಕರೆಂಟ್, per unit area ಅಂದ್ರೆ current density. So here J is a current density divided by unit potential gradient. What do you mean by potential gradient? Potential gradient is nothing but electric field. I think you have studied. Electric field is always equal to the negative potential of the, negative gradient of the potential until study ಮಾಡಿದ್ದಾರೆ second purely. So electric field is nothing but potential gradient. That's why electrical conductivity is defined as ratio of current density per unit potential gradient. Okay, simply sigma is represented as sigma equal to J divided by E, current density divided by electric field. Okay, so this is the basic definition for electrical conductivity, and this particular equation is called as Ohm's law, or this is equivalent to Ohm's law, V equal to IR. So at the end of the class, I will show you how this sigma equal to J divided by E gives you Ohm's law, V equal to IR. This is equivalent to V equal to IR, where sigma is called as conductivity, which is the reciprocal of resistivity. And conductivity is constant for a material. For a copper, it is constant. For an iron, it is constant. Okay, it is independent of dimension. It is constant for a material. On the element, it is constant. Okay, you remember this. So this is the equation, sigma equal to J divided by E, or you can write J is equal to sigma into E. Okay, what is the unit of electrical conductivity? SI unit of electrical conductivity is ohm to the power minus 2, meter to the power minus 1. Otherwise, mho per meter. It is also represented as Simon per meter. It is Simon, not second. It is Simon per meter. That is the unit of electrical conductivity. Okay, ಕೆಲವೊಂದು ಕ್ವಶನ್ ಬಂತಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಕಂಡಕ್ಟಿವಿಟಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ ಅಂತ ಪ್ರಾಬ್ಲಮ್ ಕೇಳಿದೆ. Finally, you have to write this particular unit. Okay, so next we'll move further. So there is a derivation of electrical conductivity, expression for electrical conductivity. It is very simple. within 6 to 7 steps you can get the electrical conductivity. Intermediate steps are very important. Okay, adu kuda nimage problem solve ಮಾಡ್ಲಿಕ್ಕೆ ಬೇಕಾಗ್ತದೆ. So let us start the derivation. This is the situation. We are connecting a conductor to a battery and electric field is applied in this particular direction. E is applied in the clockwise direction and electrons will flow in the opposite direction. Electron E kade flow ಆಗ್ತದೆ. Okay, when an electric field E is applied to an electron of charge E, small e is the charge of the electron of a metallic rod, the electrons will move in the opposite direction to the applied field with velocity equal to Vd. What is Vd? Vd is called as drift velocity. So electrons will acquire a constant velocity called a drift velocity, and this drift velocity is observed because of the application of electric field. Drift velocity is acquired, that means it is getting accelerated. Andre, some force is applied on the electron to acquire this velocity, and that force is called as Lorentz force or electric force. What is that electric force? That force equal to charge into electric field. What is the charge on the electron? E, small e is the charge on the electron into electric field applied. Charge into electric field is gives you a Lorentz force or the electric force. You always remember electric force is represented as charge into electric field. How to represent magnetic force? Magnetic force andre QVB, charge into velocity into magnetic field. ಇದು ಎರಡು ಫೋರ್ಸ್ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. Electric force is represented as product of charge into electric field. Okay, magnetic force is represented as charge into velocity into magnetic field, QVB. It is E into E. So this is the force acting on the electron. Next, we will apply Newton's second law. This force is known as a driving force of the electron. Due to this force, the electron gains acceleration A. So acceleration A is observed for an electron. So according to Newton's second law, this force can be represented as mass into acceleration. So electric force is represented as charge into electric field. According to Newton's law, force is also represented as mass into acceleration. From the above equation, ಎರಡು equation equate ಮಾಡ್ರಿ. One equation is force equal to E into E. Second equation is force equal to M into A. Equate them. You will get MA is equal to E into E. Therefore, the acceleration of the electron in the presence of electric field E is given by A is equal to EE, small e, capital E, divided by M. So first step alli ಏನು ಮಾಡಬೇಕು? We have to get the acceleration of the electron. Using that, you can find the drift velocity. Okay, so this is the first step. By equating the two equations, you will get the acceleration of the electron. One ಸಿಗ್ತದೆ. Next, now acceleration is represented as velocity by time. ಈ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಅಕ್ವೈರ್ ಮಾಡಲಿಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ಬೇಕು? ಇಟ್ ನೀಡ್ಸ್ ದ ಟೋ ಅಮೌಂಟ್ ಆಫ್ ಟೈಮ್. ಆಲ್ರೆಡಿ ಐ ಹ್ಯಾವ್ ಡಿಫೈನ್ಡ್ drift velocity is the constant velocity. To acquire this drift velocity, the electrons needs the time equal to relaxation time. Okay, that's why acceleration is velocity by time. The velocity acquired is Vd, time taken is tau. Therefore, acceleration is given by Vd by tau. Okay, Vd by tau. Otherwise, this Vd is equal to acceleration into relaxation time. Now you put the expression for acceleration. Acceleration again expression banittu. You have this expression. A is equal to EE by M. You put this expression here. The acceleration is EE by M anta substitute madri. You will get the expression for Vd. You will get expression for drift velocity of the electron. ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ವೆಲಾಸಿಟಿ ಎಷ್ಟು ಇರ್ತದೆ? ದಟ್ ಈಸ್ ಗಿವನ್ ಬೈ Vd is equal to EE divided by M into tau, where small e is charge of the electron, capital E is electric field, m is mass of the electron, then tau is the relaxation time. Okay, then the Ohm's law, already I have defined. Ohm's law states that current density is expressed as J equal to sigma E or sigma equal to J by E. Okay, it is given by sigma is equal to J by E. We need this sigma. Okay. Now we'll take another expression for current density. This one expression, Ohm's law prakara. We can get the current density. Current density means it is current per unit area. So basically, J equal to NE into VD. Number of electrons present in the unit volume of the sample into charge of the electron into velocity. I think you came across this particular expression. Current equal to NEVD into A and the expression. Okay. Have you remember that? Current through a conductor. And the PU second year and also in the second semester, I think you have studied. Current through a conductor I is equal to N into E into VD into A and capital A. What is A? Area of the conductor. A and E you'll get. So just I will show you. Okay. The expression I is equal to NE into VD into A. Okay. So therefore, you will get I divided by A is equal to I divided by A andrenu, it is current density J. Okay, J is equal to NE into VD and the. Okay, have you come across this expression?
Yes, sir.
This equation number. So I equal to NE VD into A and the expression. So if you take A here to the other side, I divided by A and current density. So current density equal to NE into VD. Okay. So this expression we have obtained. Okay. This is basic expression for current density. Now you apply this VD here. VD expression we have got expression for VD, that is EE by M into tau. You substitute here, and finally you get the expression for J and compare that expression with J equal to sigma and get the expression for sigma. Okay, we'll move further. Next year, substituting for VD. So J equal to NE into VD. What is VD? VD is EE by M into tau. So substitute here. NE equal to EE by M into tau. Okay. Or I can take this capital E outside, tau inside the bracket. And finally, I will get J is equal to NE square tau divided by M into capital E. Okay. Yakena E and separate it in order to compare this equation with the Ohm's law. Okay. So just simplification. Substitute for VD. VD get substitute madre. Then J equal to NE E tau divided by M into E. Open the bracket. You will get NE square tau divided by M into capital E. Then comparing with Ohm's law, J equal to sigma E. J equal to sigma into E. What is sigma here? Sigma is NE square tau divided by M. So this is the expression for electrical conductivity. So this is a simple derivation, but it is going to be very important derivation in the free electron theory of metals. So okay, munde yella kade nimge sigma express madabekandre, if you want to express the sigma, you should apply this equation only. Okay, ide equation you apply madabeku, right? Okay, so this is the derivation. ಸೊ ಮುಂದೆ ಸ್ವಲ್ಪ ಒಂದು ಸಣ್ಣ ಡಿಸ್ಕಷನ್ ಇದೆ. ಸೊ ಡೆರಿವೇಶನ್ ಡೌಟ್ ಇದೆಯಾ? ಐ ವಿಲ್ ರಿಪೀಟ್ ಇಟ್ ಒನ್ಸ್ ಅಗೇನ್. ನೋಡ್ರಿ, ಫಸ್ಟ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಏನ್ ಮಾಡಬೇಕು, ವಿ ಹ್ಯಾವ್ ಟು ಅಸ್ಯೂಮ್ ಎ ಕಂಡಕ್ಟರ್ to which an electric field is applied by means of a battery. Electric field E is applied. Charge of the electron is small e, and it will acquire the drift velocity Vd. It will get accelerated. Then force acting on the electron is E into E. Then apply Newton's second law. According to Newton's second law, the force is given by m into A. Equate these two equations. So force m into A should be equal to force E into E. Therefore, you will get the acceleration. Okay, acceleration 6. Next, acceleration A is equal to drift velocity by relaxation time. Velocity by time. So therefore, you will get the drift velocity Vd is equal to acceleration into time tau. Then you substitute for acceleration. Vd equal to EE by m into tau. Vd ಗೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಸಿಕ್ತು ನಿಮಗೆ, ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ. ದೆನ್ ಇದು ಒಂದು ನಿಮಗೆ ಜಸ್ಟ್ ಹೇಳಿದೆ, ಇದನ್ನೇ ಡೈರೆಕ್ಟ್ ತಗೊಂಡ್ರೆ ನಡೀತದೆ. ಬಟ್ ಕರೆಂಟ್ ಡೆನ್ಸಿಟಿ ಇಸ್ ರಿಪ್ರೆಸೆಂಟೆಡ್ ಆಸ್ ಜೆ ಈಕ್ವಲ್ ಟು ಎನ್ ಇ ಇಂಟು ವಿ ಡಿ. ಇದು ವಿ ಡಿ ಸಿಕ್ತು. ಸೊ ದೆನ್ ಜೆ ಈಕ್ವಲ್ ಟು ಎನ್ ಇ ಇಂಟು ವಿ ಡಿ. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಫಾರ್ ದಟ್ ವಿ ಡಿ. ಸೊ ಜೆ ಈಕ್ವಲ್ ಟು ಎನ್ ಇ ಇಂಟು ವಿ ಡಿ. ವಿ ಡಿ ಇಸ್ ಇ ಬೈ ಎಂ ಇಂಟು ಟೋ. ದೆನ್ ಯು ಸಿಂಪ್ಲಿಫೈಡ್ ಫರ್ದರ್, ಕೀಪ್ ದಟ್ ಇ ಔಟ್ಸೈಡ್. ಇ ಅನ್ನು ಹೊರಗಡೆ ಇಟ್ಕೊಳ್ಬೇಕು. ಯಾಕೆ ಹೊರಗಡೆ ಇಡಬೇಕು? ಇನ್ ಆರ್ಡರ್ ಟು ಕಂಪೇರ್ ದಿಸ್ ಇಕ್ವೇಶನ್ ವಿತ್ ದಿ Ohm's law, that is J equal to sigma into E. Okay, so J equal to NE square tau divided by M into E ಅಂತ ಬರ್ತದೆ. So this term is called as electrical conductivity sigma. Therefore, you will get sigma is equal to NE square tau divided by M. Okay, so this is the simple derivation for electrical conductivity. This is going to be very important. Is it bhಳ important derivation where I can small discussion is there.